We will continue our discussion on mathematical induction. We will see some more case studies. So consider a 2 cross 2 chessboard. So from this I remove one square. Say let me remove this. Then what you get is these three. This I call it as L-shaped. Three squares are there. So it's called triomino. So you remove this square, you get this. If you remove this square, you get triomino of this shape. And you remove this square, you get triomino of this shape. And remove this, you get triomino of this shape. And you get triomino of this shape. So given a 2 cross 2 chessboard which has 4 squares, you remove any one. You are left with 3 squares, which I call it as triomino. In particular, they are L-shaped triominoes. Now we are going to work with this to solve a related problem. So the question is this. So you are given, say, 4 cross 4. Something like this. From this 4 cross 4 chessboard, one square is removed. So minus one square. That could be any one square. So you are given this 4 cross 4 chessboard, minus one square from this is removed. It could be any one square. Now the question is this. So can 4 cross 4, just for my convenience, I'll write it as minus 1. When I say minus 1, from 4 cross 4 chessboard, some one square is removed. So can 4 cross 4 minus 1 chessboard, can this be filled with L-shaped triominoes? You can use any of this, and any number of times you can use each of them and fill the rest. Meaning, suppose I say this square is removed. Now can you fill the rest of the squares with these L-shaped triominoes? Meaning I will use one L-shaped triomino to fill this and one more to fill this, like that. Can we start filling the remaining squares using L-shaped triominoes? That's the question. Let's make an attempt, see whether this 4 cross 4 minus 1 can be filled using L-shaped triominoes. So here is one arrangement. For example, I have placed one L-shaped triomino, one more here, one more to cover these three, and so on. So now here is an arrangement for this 4 cross 4 minus 1, and which can be filled using L-shaped triominoes. Now let's generalize this. Meaning, in case you want to see one more, we can take one more. It could be any one square. Suppose this square is removed. So what we can do is, I'll fill this with the L-shaped triomino, and this one with this one with this. So here is an here is a placing of L-shaped triominoes on the rest of the squares. Now we are asking this. So given 2 power k cross 2 power k minus 1, meaning from a given 2 power k cross 2 power k chessboard, some one square is removed. So given this chessboard, so can 2 power k cross 2 power k minus 1 board, can this be filled using L-shaped triominoes? That's our question. So it could be 8 cross 8 minus 1, it could be 16 cross 16 minus 1, it could be any 2 power k cross 2 power k minus 1. The one that I remove, it could be any one square. Now we are asking, if this is the case, can this be filled using L-shaped triominoes? As always, let's make an attempt using induction. So proof by mathematical induction. Okay. So let's look at the base case. So k cannot be 1 because you need at least 3 squares for L-shaped triomino itself. So you will have to start with 2. So k is 2. We have just now shown how to fill this. So from 2 cross 2, you may remove this square, or you may remove this, or this, or this. And in all, we know this can be filled using this triomino, this triomino, this triomino, this triomino. So base case is done. So given a 2 cross 2 minus 1 chessboard, it can be filled using L-shaped triomino. Let's look at the hypothesis. So hypothesis, assume for k greater than or equal to 2, remember the lower bound is precisely proved as part of base case. Assume for k greater than or equal to 2, 2 power k cross 2 power k minus 1 board, chessboard, can be filled using L-shaped triominoes. Okay, so let's look at the induction step. So induction step, we are given 2 power k plus 1 cross 2 power k plus 1 minus 1. Some one square is removed. So we are given this chessboard. We want to know whether this can be filled using L-shaped triominoes. Correctly, yeah? Let's look at this. Okay. One can visualize 2 power k plus 1 into 2 power k plus 1 minus 1 as follows. Remember, I need to bring in induction hypothesis as part of induction step to complete our approach or proof of correctness. What I do is the following. See, you are given 2 power k plus 1 cross 2 power k plus 1 minus 1. 2 power k plus 1 into 2 power k plus 1 can be visualized as 4 copies of 2 power k into 2 power k. So each one has 2 power k cross 2 power k. See, for example, you take this 4 cross 4, this can be visualized as 2 cross 2, 2 cross 2, 2 cross 2, 2 cross 2, 4 copies of 2 cross 2. Similarly, 8 cross 8, you can see it as 4 copies of 4 cross 4. So in general, 2 power k plus 1 cross 2 power k plus 1 can be visualized as 4 copies of 2 power k cross 2 power k. Correct? Why am I doing it? Because I want to bring in hypothesis. To bring in hypothesis, I need this board. And in this board, one square is removed, minus 1. We don't know from which quadrant it is removed. It could be any one. Let me assume somewhere here it is removed. Okay. Somewhere here it is removed. So which means this one, you can visualize this as 2 power k cross 2 power k minus 1. Okay. So now, this part of the board, one can apply hypothesis, because hypothesis says given 2 power k cross 2 power k minus 1, you can fill them using L-shaped triominoes. But I cannot apply hypothesis here because the premise of the hypothesis says 2 power k cross 2 power k minus 1, but this one is 2 power k cross 2 power k. So to bring hypothesis in each of this, I need to remove one square. So what I do, because I am going to bring hypothesis, I am removing this corner square from this board. I am removing this corner square from this board. I am removing this corner square from this board. Okay, this is in your hand because I am running the proof. I have the control over these three. This is given by the user or the input. So some one square is removed. We don't know where that is. Without loss of generality, assume that it is in this quadrant. It could be any one square. Now that component or that quadrant will be 2 power k cross 2 power k minus 1. By induction hypothesis, this can be filled using L-shaped triominoes. Fine. Now look at this. Now this is 2 power k cross 2 power k minus 1. Again this one is 2 power k cross 2 power k minus 1. Again this is 2 power k cross 2 power k minus 1. Now by induction hypothesis, each of this, now this is also 2 power k cross 2 power k minus 1. Now each quadrant is 2 power k cross 2 power k minus 1. So by induction hypothesis, each quadrant can be filled using L-shaped triominoes. Correct? And we have removed corner square from each of them. That has to be filled. So simply use one L-shaped triomino to fill this. So I did not remove some arbitrary square from each of them. Instead, I carefully removed the corner square so that these three can be filled using L-shaped triomino. So we know that the rest of this can be filled. We know the rest of this can be filled. Who will give us the hypothesis? We know that the rest of this can be filled. But these three, the hypothesis will not do the filling. So, but these three are adjacent. I am filling them using one L-shaped triomino. It is this reason why I have chosen corner square from each of them, so that I can fill this using one L-shaped triomino. The rest of them will be filled using induction hypothesis. So that's all. Now with the help of induction hypothesis, we have shown any 2 power k plus 1 into 2 power k plus 1 minus 1 can be filled using L-shaped triominoes. Therefore, the claim is true for any k greater than or equal to 2. So let me repeat. For k is equal to 2, you are given 2 cross 2 squares. The one that you are removing could be anything. If you remove this, then here is L-shaped. If you remove this, here is L-shaped. So each of this possibility can be filled using appropriate L-shaped trinomial. Then what I do, I assume for k greater than or equal to 2, 2 power k cross 2 power k minus 1 both can be filled using L-shaped trinomials. We should make use of this to complete the induction. Let's take 2 power k plus 1 into 2 power k plus 1 minus 1 chessboard. The one that we are removing, it could be any one square. For example, from this, I may remove this, I may remove this, this, it could be anything. Then to bring induction hypothesis, what I do, I see this as 4 copies of 2 power k cross 2 power k. Fine. Then one of them will contain this missing square. Without loss of generality, you mark that square. Say let this be this quadrant 3. Now this is 2 power k into 2 power k minus 1. By induction hypothesis, this can be filled using L-shaped trinomials. Now to bring hypothesis in these 3, from each of them I remove the corner square, so that it becomes 2 power k cross 2 power k minus 1, and apply induction hypothesis in each of them. Since I have carefully removed the corner one, this can be filled using L-shaped trinomials. Do not remove any arbitrary square from each of them. If you do it, then you will not have control over how to fill the L-shaped trinomial for the rest of them. The 3 of them that you have removed, we don't know how to fill it. And one should have a control over the proof, meaning one should bring the hypothesis in a clever way, which is why I am removing this corner square. Because hypothesis says given 2 power k cross 2 power k minus 1, this minus 1 could be any one square. It could be this, it could be this, it could be this, it could be this. I am carefully choosing this so that I can fill this using L-shaped trinomials. And because over here it is universal quantifier, meaning it could be any one square, so I can as well remove these 3. That's all. So this says the proof is complete following mathematical induction. Therefore, for all k greater than or equal to 2, any 2 power k cross 2 power k minus 1 chessboard can be filled using L-shaped trinomials. There are variants of this. One can ask, a board of this is given, can it be filled using dominoes, which is 2, and tetrominoes, which is 4, and so on, which we will see as part of our assignments and problem session. Also, and the significance for 2 cross 2, 4 cross 4, 8 cross 8, in general 2 power k cross 2 power k, and the induction works for 2 power k cross 2 power k. And one has to check whether 5 cross 5 minus 1 can be filled using trinomials, 6 cross 6 minus 1 can be filled using trinomials, and all that. If not for any one square, maybe some it may be possible, or it may not be possible for any one. So all that one has to experiment and see, which we shall see as we shall discuss as part of our assignments and problem sessions.